All right, in chapter 1, we have to spend a little bit of time talking about scientific notation. Um, Scientific notation is one of those things that you're going to see me throughout the semester moving back and forth between the different units like microns and 10 to the minus 6, or centimeters and 10 to the minus 2, because I've been doing this long enough that when I see centimeters, my brain automatically converts to 10 to the minus 2 meters. Eventually you'll do that. It'll take a while, but eventually you'll get there. Some of the things you'll have to get accustomed to and will have to look at with your calculator is, how does your calculator do scientific notation? Um, for example, 1000 is 10 to the 3. Well, some calculators write this as 10 to the 3. Other calculators write it as 10e3, and that means exactly the same thing as 10 to the 3, right? So depending on your calculator, the representation is going to be different, right? Is going to be different. Things we'll use all the time, we'll use mega. We may use giga on it. We will use giga second semester more than first. Mega a lot. Kilo, not really. Hecto and deca are deci, but centi and milli and micro and nano, right? These are all units that we will be using on a regular basis. These are modifiers, right? Scientific notation modifiers to units we'll be using on a regular basis. So a megameter is 10 to the 6th meters. Not that we ever say megameters, but we say kilometer all the time. A kilometer is 1,000 meters. Why do we use scientific notation? Well, I do it because I'm lazy, right? That laziness means I don't want to spend a lot of time counting zeros. So here we have 1.6 times 10 to the minus 19 coulombs. That's a charge on the electron. And the electron, if we wrote that out, 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 wrong, right? And over here, if, well, okay, because they're next to each other, we can kind of compare them. But imagine comparing this to that. In fact, I'm going to do this. I'm going to take this. I'm going to put some space in there. All right. And now imagine having to, I'm going to move that over. Okay. So now imagine having to compare these two without scientific notation. All right. You're going to spend all day just going, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 10 to the minus 19. And you're going to come down here and you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 10 to the minus 18. Right. So, but if I write it as 1.6 times 10 to the minus 19 and 1.6 times 10 to the minus 18, you automatically, immediately know which one is larger. All right, scientific notation, very important in terms of dealing with the kinds of numbers we have to deal with. All right, that's it for this bit.